phenol. First, let's take a look at acidity. So actually, acidity is the ability of a compound to release a proton. The dissociation of acid will produce conjugate base, and acidity is determined by the stability of the conjugate base of an acid. Therefore, anything that will stabilize the conjugate base will make the acid more acidic. We can say that the higher the stability of the conjugate base, the higher the acidity. Next, let's take a look at the acidity of phenol. So actually, phenol will dissociate to form phenoxide ion and also hydrogen ion. So the phenoxide ion is very stable because the electron can be delocalized into the benzene ring. So the acidity of phenol is due to the delocalization of the negative charge of the phenoxide ion, which causes the ion to be stabilized by the resonance effect. How? Let's take a look at the next slides. So this is how the delocalization of electron is happen in the phenoxide ion. Due to delocalization of electron, the stability of conjugate base is increasing. Now let's compare the acidity of phenols, alcohol, and water. So alcohol, water, and phenols are classified as weak acid because it acts as proton donor in aqueous solution. So alcohol is the least acid, followed by water, followed by phenol. Phenol is the most acidic when compared to the other two. And the question is why? As I mentioned earlier, when the conjugate base is stable, the acidity also will be increasing. Okay, so when we look at the dissociation equation for phenols, alcohol, and water, we can see that the phenoxide ion is the most stable. Therefore, the phenols is the most acidic compared to the other two. As for methoxide ion, it contains the R group, CH3. And we know that the R group, the methyl group, is the electron donating group. We know that the electron donating group will push the electron density towards O, and the O is already has the negatively charged. Lepas tu metil bagi lagi charge negatif. So ini akan menyebabkan stability of the methoxide ion decreasing. Okay, so dalam case ini the electron donating group will destabilize the conjugate base. Okay, itu sebabnya methoxide ion is less stable compared to hydroxide ion. So bila methoxide ion is less stable than hydroxide ion, it will make the methanol is less acidic compared to water because of the presence of alkyl group that will increase the density of negative charge on the oxygen atom. Jadi, methoxide ion less stable compared to hydroxide ion, dan phenol is the most acidic because the phenoxide ion form is stabilized by the delocalization of negative charge into the benzene ring. Okay, now let's take a look at reaction of phenol with sodium metal. So addition of sodium to a solution of phenol in ether at room temperature produce phenoxide salt and hydrogen gas. So this is the reaction equation for this reaction. Phenol also will react with sodium hydroxide. Okay, we know that phenol is slightly soluble in water but dissolved in aqueous solution of NaOH at room temperature to produce sodium phenoxide and water. So this is the reaction equation between phenol and NaOH. Next, normal alcohol are unreactive towards NaOH due its nature as a weak acid. This is because phenol is more acidic than aliphatic alcohol. So when we are writing the reaction equation between cyclohexanol with NaOH, there will be no reaction. Therefore, the reaction of phenols with sodium hydroxide is often used to distinguish phenols from other alcohols. And finally, let's take a look at identification tests for phenol. There are two types of identification tests. The first one is bromine water test, and the second one is FeCl3 solution test. So the reagent for the bromine water test is bromine in water. Condition is at room temperature, and the observation is reddish brown color of bromine will decolorize and white precipitate form. Okay, so this is the equation for the bromine water test. Next, let's take a look at the FeCl3 solution test. The reagent used is FeCl3 solution at condition of room temperature, and the observation is formation of purple complex. So this is the equation related to the FeCl3 solution test.